is PowerPoint. Just relaunch it, I think. Just escape. And F5. This way. Yes. Yes. Now you can do your PowerPoint. The pointer is this one.
Good morning. Bonjour à tous. Je suis SEKINE from Meiji University. The title of my presentation today is Analog Integrated Circuit and its application to AI system. Physical quantity is in the natural world is analog, almost analog, such as radio wave and sound and bioinformatic data and temperature and so on. The analog data is converted to data, and data signal processing is very useful for mobile electric equipment and radio communication. Analog circuit is very important and necessary for electric devices, but sometimes analog circuit is called unsung hero, en français, les héros l'ombre. In Japanese, 縁の下の力持ち。It is not negative word, I think. It is very positive because analog circuit has a chance to be used in the various fields. So, in our study, we focused on the AI system, AI, artificial intelligence. It is very recently, it is very used to everywhere in near day. So first, I read the AI. This is a figure of AI conception. The biggest area shows artificial intelligence. AI is used to solve the problem immediately. A middle green circle shows machine learning. Machine learning is included in AI. The purpose of machine learning is find new things. And the smallest circle shows DL, deep learning. Deep learning is included in machine learning. Deep learning is used to learn rules. So in our studies, we focus in the two topics. One is machine learning, that is the photonic curve systems. In this system, we use analog circuit. And the other, second, is deep learning application, photonic reservoir system. Photonic reservoir system, in where we use analog circuit. So next, we focused in the AI system by collaboration with photonics area. So now we compare the electronics and photonics. Both of them have merit and demerit. First, left side, analog circuit. The merit of analog circuit is very high speed operation by RF communication circuit. And with low power, small number of transistors. And it can be realized on small chip area. But the merit of analog circuit is low calculation accuracy, and it has nonlinearity characteristics, and also when realized in IC, an avoidable process variation is not is there. On the other hand, in the area or in the field of photonics, merit is very high speed processing and low power. It is very good characteristic in photonics. But in photonic circuit, it is very difficult to the complex calculation. Nonlinearity calculation is not is very difficult for photonic circuit. So we work on the fusion of analog circuit and photonic circuit. Although the analog circuit has demerits such as nonlinearity, but we accept of imperfection because we estimate the result as a system level result. So the first topic is reinforcement learning system employing analog circuit. We focus in the bandwidth problem. Bandwidth problem is well known. So I will show you an example. This slot machine is very useful to explain the bandwidth problem. There are two machines, A and B, and this boy is going to select the machine which will give him more reward. So he tried to play each machine, and if in this case machine A gives very good reward to him, so he selected machine A is good. So a bandit problem is to search the best result from multiple candidates from a machine with maximizing the reward. This system can be used to our electric applications such as online routing in communication system and also frequency allocation in wireless communications. So now we are studying in the analog IC solving two armed bandits problem. This is the concept of the two-armed bandit problem solving system using laser curves. This is the laser curve. Laser curves means the generated semiconductor. Why laser curves used? Because laser curves is very high speed signal generator. It may be 20 gigahertz is possible. So this block diagram is shown here. The block diagram is written in the comparator selection circuit, AHS circuit. There are three block diagrams. So this block diagram can be realized by software level, such as MATLAB or Python. And in a real world, digital processing can realize this block diagram. But with this data processing, the performance is not good because low speed, and also large IC area. So laser scouts is very high speed signal, but it is too over spec for this data processing. So we designed the analog circuit which operate very high speed operation. We use some analog circuit to incorporate this block diagram. A comparator is shown the left figure. It is different. It consists of a differential amplifier, and it has a latch and limited output. This block comparator operates up to 8 or 9 gigahertz. It's very high operation because it is employed to RF applications. And the middle is a selection circuit. In this circuit, a transmission gate is used to make operate in high speed. And light circuit shows AHS circuit. It means the analog history straight circuit. In this analog circuit, the straight is not digital. This analog data is read in the capacitor of CL. And this is the simulation result of our systems. The vertical axis shows learning time, and the horizontal axis shows learning time, and the vertical axis shows output voltage of the systems. You can see the black line is the change point of the probability. And before that, the machine A has a probability of 0%, and machine B has 100%. So machine B is selected. Output voltage is 1.3 volt. And after that point, the probability was changed. Machine A is 80% and machine B is 20%. So learning is start and proceeding a little bit, and about 100 nanoseconds, machine A has been selected. In this result, the system is completely operated, I see. And the clock is higher, such as 5 gigahertz or 7 gigahertz. It takes a long time to select the machine, but it works well. We have already fabricated this circuit with TSMC 180 nanometer, and now we are measuring it with probing and also PCB circuit. So we talk about the next topic. We are studying in photonic reservoir computing with analog max circuit. This is a diagram of photonic and electronic reservoir systems. Upper figure shows the conventional and previous concept. Blue area shows the photonic reservoir, which is studied in the collaborative researchers, and we research on the calculation of the multiply sum circuit. The red area. The problem to be solved is, in this case, photonic reservoir operates very high speed, but to calculate the project sum have to be done in offline process. So the goal of our research is to realize real-time processing. Real-time processing and analog integrated circuit with analog integrated circuit, multi project sum will be obtained by analog circuit and combine the photonic circuit and electric circuit. And this is a circuit card diagram or multi-product sum circuit. It is a differential circuit. I think you know the Gilbert cell. It is a fundamental circuit, and it is the first step of the Mach circuit. And this shows the differential and two input circuit shows the PD1 photodetector, which is convergence from photonic to electronic. So there needs 7 input, so we can connect the basic Gilbert cell in parallel, and some will be obtained. We designed and simulated DC analysis and laid out that schematic result and post-layer smear. There are a little difference between them, but there are a little nonlinearity around V equals 0, but the maximum error is within 1.5%. It's corresponding to 5 millivolts in the real voltage. So we have already fabricated this circuit with TSMC 65 nanometer, and we have already measured with photonic reservoir circuit. But this result, in detail, we will be presented in ICCS 2024 in Nancy, this November. So I conclude my presentation. Now, integrated circuits are expected to fuse the photonic circuit. Nonlinearity caused by MOSFET and uncertainty caused by offset and noise will be accepted for entire system performance. Boundary between photonics and electronics can be optimized for entire system performance. Thank you for listening.
If anybody has any question.
I have one question, Yori,
Hi.
about AI.
Yes.
It's not about the circuit design, but when you see the convergence,
Yes.
you show that which tool did you use to perform the AI operation? Which tool or software did you use to perform the AI operation?
Which? Yes. So before that, we co-founded with software simulation.
Okay.
Yes.
But what was the protocol, or I don't know you call that, the modeling of the AI? The specific software, like there is TensorFlow in Python, I think does it now or whatever.
Yes, and it is only the realize this block diagram.
Okay.
Yes.
Okay, block diagram for AI simulation.
Yes.
And then when you implement that, well, you have the circuit measurement.
Yes.
When you have hybrid, I mean software and hardware together for this.
Yes, and this simulation result is obtained by SPI simulation.
Okay.
Yes, and there are a little difference between software and SPI simulation.
Okay.
Yes.
Thank you for presentation, and I'm learning about computer science. So let me show the slide next to the reward slide. Yes.
Yes.
How to give the reward to the subject. For example, human, judge it human and give signal manually.
It prepare the table of the reward. So it is by the result of selection circuit, it will be given by the table.
So give circuit by human.
Not there are list. The data list is prepared.
So give the reward digitally. User model.
In this case, the reward is if you win, you can one increase, and not win, one decrease, and one step is reward in this case.
Thank you so much for this interesting presentation. My question is about the merging of photonics and electronics. Electronics, most of the time, is done by CMOS in silicon technology. Photonics, well, CMOS silicon is known and cannot do the emission of any photon. It can receive them, and it cannot, because of this gap, it cannot emit any photon. So, how can you? Is there any material or any future option that can allow us to have a co-integration of both the photonic circuit and the electronic circuit on the same substrate? Because it looks like silicon will not be the good candidate for that, because it will not be able to make a transmitter. Have you any idea of how can we merge the two circuits, the photonic one and the electronic one, on a single chip? That's a chip or whatever.
Yes. We found that process which included photonic and electronic. And the foundry is EPIC process. Will be possible to fabricate it both photonic and electronic. But we can not fabricate it because of another reason. So now we are going to the high-speed silicon germanium bipolar and photonic process in IHP process and separate it, and photonic reservoir and photodetector, and the output is current, and we receive the current input, and the print body is realized to combine two circuit, photo and electric. We plan it.
Thank you.
Is there any other question? So thank you very much, Professor.
Thank you.
Now we have introduction to learning-based motion control on mobile robots with kernel method by Prof. Tatsuya Ibuki.
May I use this one?
Yes,